Welcome to my YouTube channel, A Binary of Civil. In this video, I am going to solve the first assignment of design of reinforced concrete structures. Okay, are you ready? Okay, let's start. You can see first question. He has given match list 1 and 2 using the options given. So in list 1, he has given the names of the codes, and in the list 2, he has given the numbers. Which number of the code will describe which code. Okay, so here coming to option 1, IS 456. So IS 456 2000 will give you Indian Standard Code for plain and reinforced concrete. Okay, so that is C option will be matched with 1. Okay, and coming to second one, IS 875 1987. This code will give you IS code of practice for design loads. So these design loads are other than earthquake loads. So for which structures? For buildings and extra structures. Okay, so that is option B will be matched with second one. And I want to tell you there are 5 parts of IS 875. IS 875 part 1, part 2, part 3, part 4 and part 5. These are very important. So part 1 will give you information about dead loads. Part 3 will give you information about imposed loads. Part 3 will give you wind loads. And part 4 snow loads. And part 5 special loads. So that is other than loads, they are of dead load, imposed load, wind load and snow loads. These are all special loads and load combinations. So these parts are very important. IS 875 will give you the design loads for structures and buildings. So in that IS 875 there are 5 parts. Part 1 will give you dead load. Part 2 will give you imposed load. Imposed load is again we call it is live load. And part 3 will give you wind load. Part 4 will give you snow load. And part 5 will give you the loads other than these 4. That is special loads and combination of the loads. Okay. And here we have excluded the earthquake loads. So for earthquake loads, which code will be given? Which code will give you us the information regarding earthquake loads? So you can see that is IS 1893 2002. So this is Indian Standard Code for earthquake resistant design of structures. Okay, so if we want to design a building which can be able to resist the loads which are coming by earthquake, so the useful code is IS 1893 2002. Okay, so that is from the options you can see here option A can be matched with option 3. Okay, and so from this option C will be matched with 1 and option B will be matched with 2. Option A will be matched with 3, that is 3, 2, 1. And finally code of practice for pre-stressed concrete. That code will be given by IS 1343. This will give you, this is a code, IS code of practice for pre-stressed concrete. Clear? So here there are the 4 lists. And what is the remaining code extra 10262? So you already know very clear about this code. This is mixed design of concrete. So this code very frequently used in concrete technology. So this for mixed design, the uses code is 10262. So the option will be, the answer will be, it is option A. Clear? So coming to next question. So these are all somewhat statements. They have given something like 4 statements. Which of the following above statements is or incorrect? Okay, so he hasn't asked what are all the correct statements. He asked incorrect statements. Okay, first of all, we need to classify the correct and incorrect statements. So, and the first statement here it is, the stress strain curve of concrete is linear and time dependent. Obviously, this is a wrong statement. How means? Let me draw stress and strain for concrete. So this code is like this much, like this. So the only some portion is initial, remaining it is parabolic. Parabolic until strain 0.002, and beyond that it will be horizontal. Okay, so the maximum strain in the concrete is 0.0035. So here it is a straight. Here it is parabolic. Here it is linear. Okay, so the stress strain curve for concrete is linear. This statement is wrong. Okay. And the second statement is concrete does not have a definite modulus of elasticity. So modulus of elasticity of concrete, I am writing here. So this is regarding first statement. This is regarding second statement. Modulus of elasticity. Modulus of elasticity, there is two terms. It is short term and long term. Short term modulus of elasticity is ECS is equal to, you will be very familiar with this formula, 5000 root FCK. And long term modulus of elasticity. Long term modulus of elasticity can be indicated by ECL. That will be EC divided by 1 plus theta. So that is 5000 root FCK divided by 1 plus theta, where theta is equal to creep coefficient. So this theta value will be ranging from 2.2 and 1.6 and 1.1. So what are all these 2.2, 1.6 and 1.7? If we load the building immediately after 7 days of construction, then creep coefficient will be 2.2. If we load the building after 28 days of construction, then it will be 1.6. After 1 year of construction, then theta will be 1.1. That is, this value is not a constant for concrete. It will be keep on changing depending upon the time of the loading. So what he has given the statement, concrete does not have a definite modulus of elasticity. Yes, it is correct. And okay, and the option 3 is, the reinforced concrete sections behave elastically at high loads. Okay, as concrete is brittle. So concrete is a brittle material, right? I am writing regarding third statement. Concrete is brittle material. So it will not behave like elastically at high loads. But he said it will behave like elastic manner at high loads. So that statement third is wrong one. And he has given regarding fourth statement. So creep definition he has given directly. Creep is time dependent strain. Time dependent deformation at constant load is nothing but it is creep. So that is whenever we apply certain load for more duration, so there is a constant deformation over that material. The type of deformation is nothing but it is a creep. So the fourth statement is again correct. So what are all the options wrong? 1 and 3 are wrong. 1 and 3 are wrong means option D is the correct answer. Okay. Next we will go to next question. He has given, so there are again 4 options regarding usage of coarse aggregates in which in reinforced concrete. So that is usage of coarse aggregates. So here usage, the first statement is the maximum nominal size of coarse aggregates should not be smaller than, that is it should be more than 1/4 of minimum thickness of the chamber. Okay. So here you can see here max nominal size of coarse aggregate should not be smaller than, that is should not be less than 1/4 thickness of member. Okay, so this is correct option. And one size aggregate should be used in construction. So in the construction, we should use well graded aggregates. Well graded aggregates means it is having all sizes of aggregates. So well graded aggregate should be used for construction. Option 3 is correct. And one size of aggregates should be used in construction. This option second is wrong. And the fourth option, for heavily reinforced concrete members, the nominal maximum size of aggregate should be either. So I will write the statement here. Nominal maximum size of coarse aggregates should be 5 mm less than clear distance between main bars. Okay, or there is one more provision given by IS code, minimum cover to the reinforcement. So out of these two, whichever is smaller. Okay, so option 4 is also correct. So for this question, answer is A option. Okay. So in this question, he has given provisions and guidelines which type of aggregates, especially coarse aggregates, we have to use in the construction. Okay, we should use a well graded aggregates in the construction, not one sized aggregates, not uniform aggregates. One size aggregates means uniform aggregates. Okay, clear. We'll go to next question. So in the next question, he has given again match. So that is the maximum size of aggregate that can be used for slab of minimum thickness of the slab is. So for option A, the answer will be maximum size of aggregate should not be greater than, in a slab, the maximum size of aggregate should not be greater than 1/4 of the slab thickness. Okay, so that is 1/4. What is the slab thickness? This is 120 mm. That is 30 mm. So in 120 mm slab thickness, the maximum size of aggregates we can use is 30 mm aggregates. So for this answer is 30 mm. Okay, that is A4. And next, coming to option B, a concrete of nominal mix proportion 1:1.5, 3. So this 1:1.5:3 will indicate generally cement is to fine aggregates is to coarse aggregates. So this will indicate 1:3:6. This is for M10 nominal mix. 1:2:4. This is for M15 mix. M10 means the maximum strength in 28 Ds is 10 MPa. The maximum strength for M15 is 15 MPa, and 1:1.5:3. This will be M20. So that is 25 MPa. So after how many days? It is after 28. This much is the minimum strength that we need to get. And finally 1:1:2. This is M25. Okay, the maximum strength will be, here it is 25 MPa. Okay, so until M25 these all mixes are nominal mixes. Okay, beyond this M20, so that is M30, these mixes are design mixes. Okay, beyond M25 the remaining mixes, M30, M35, something like these are all mixes are design mixes. So for this he has given 1:1.5:3. 1:1.5:3 is M20. So how many days it is? 20. So for B it is 2. 2 means it is 20. And minimum diameter of HYSD bar is, obviously it is 8 mm. 8 mm means C it is 2. Okay, B it is 3. And 4, 3, 2 is the answer. Answer is B. So for this answer is B. So you can see here it is answer B. Clear? And we'll go to next question. It's a basic definition that you need to know. So what is the definition that there he has given? What is a characteristic strength? So I'll write the definition here. Characteristic strength means the value of the strength below which not more than 5% of test results are expected. Okay, so not more than 5%. For example, if we have taken a mix M20 means we need to get 20 MPa for 95%, more than 20 MPa for 95% of the results, and less than 20 MPa for only 5% of the results. For example, if we have made 100 cubes of M20 nominal mix design, in 100 cubes we need to get all the cube strength more than 20 MPa of 95%. Out of 100, 95 cubes we need to get 20 MPa, and only 5 cubes are less than 20 MPa. So that is the meaning of characteristic strength. Clear? So option D is correct answer. And so it is a direct formula. Next question. Modulus of elasticity of concrete is equal to 5000 root FCK, whatever be the FCK value. So for M10 FCK is 10, for M20 FCK is 20, for M25 FCK is 25, like that. So here he has given M25. So M25 means FCK is 25. So root 25 you will get it is 5. It is 25,000. Clear? So option B is the correct answer. And coming to 7th question, workability of concrete is measured by. So you can remember VB consistometer and compaction factor test and slump cone test and flow table test. And in the slump cone test there is one more type of test, it is K slump cone test and Kelly ball test. These are all the different tests available to calculate workability of concrete. Okay, so out of all the tests he has given option B is the correct answer. It is a slump cone test. By using slump cone test we can able to calculate the workability of concrete. Okay, and generally in RCC design, next question, which of the following loads is not considered with earthquake load? So obviously wind load will not be considered along with earthquake load. Both wind and earthquake will not come together. This was defined by Indian code, IS code 456/2000. Okay, so IS 456 code says both wind and earthquake will not be considered at same time. So for that reason, whenever we are taking earthquake load into consideration, we need to exclude wind load, or else both of the maximum of earthquake and wind load, either of these we can take maximum value. Okay, so the option will be answer D. And total shrinkage strain, you just need to remember 0.0003 as per IS 456. As per IS 456, total shrinkage strain is equal to 0.0003. You need to remember this value very directly. It's a direct question. And I already explained what is a characteristic strength. Characteristic strength is the strength value below which 5% of the test results are expected to fall. Okay, if we have taken M20 concrete, so the 28-day strength of this M20 concrete is 20 MPa. For example, if we have taken 100 cubes, out of 100 cubes, only 5 cubes are less than 20 MPa, remaining all greater than 20 MPa. So that is the meaning. Okay, here he has given the last question. For cubes casted with M30, so he has taken M30 concrete. So this is the last question. So M30 concrete, what is the number? How many number of cubes he has taken? It is 300 cubes. Out of 300 cubes, strength more than 30 MPa. Out of 300 cubes, for how many cubes the strength should be more than 30 MPa? As per definition of concrete, characteristic strength of the concrete, 95% of cubes should have strength greater than 30 MPa. So that is 95 into 300. So you will get it is 285 cubes. So out of 300, 285 cubes, we need to get the strength value more than 30 MPa. So finally the answer will be 285. Clear? So in the starting there are very conceptual questions are there in this assignment, and in the latter stages there are direct questions. Okay, so listen carefully, write the content in a separate notebook and practice all the questions. If you have any doubt, post a comment below. Okay, thank you.